And now we want to talk about molecular bound, type of the molecular bound. So here we want to discuss Cl2, HCl, NaCl, H2O, and glucose fructose, see which one is polar or not. Also CO2. Let's just go to the next page. This is electronegativity table. For each element, you see a number. These number tell you how electronegative is that atom. Higher is the number, it's the atom saying the atom tend to attract the electron more. So for example, H is 2.1, Li is 1. Of course, H is tending to take electron more than Li because 2.1 is more than 1. Anyways, as you see, the numbers here, 4 are pretty high, so they're very electronegative. And this one is pretty low, is not that electronegative. They want to lose electron more than taking electron. Okay, so without further ado, let's just go to the example. For the Cl2, I know the Cl has 7 electron in a valence, right? 7 electron in a valence. I put another Cl2, another Cl. Here, 7 electron in valence. So there will be a bound between these two electrons alone. So I just put it as a dot. I want to see what type of bound will this make. Is it polar or non-polar bond? See, electronegativity of the Cl, I'm just going 2.9, and here is 2.9, right? They tend to take electron in the same manner. That's why this bond is not going to be polar. The electron will be always in a space somewhere between these two atoms. So it's non-polar. Non-polar. We can say 2.9 minus 2.9. The electronegativity of the first one and minus the second one is 0. As you see, if the difference between the electronegativity is between 0 to 0.4, it is covalent, non-polar. Non-polar, covalent. Covalent. Okay, that's the one. Another example is NaCl. I put it here. Na I know is a positive, Cl is negative. So look at Na here. Na is 1 and Cl is 2.9. Therefore, 2.9 minus 1 is equal to add 1.9. So if you look at this table, I want to change this one to 1.7, guys. It's a little bit overrated. So 1.7. So from 1 to 1.7, that's going to be covalent. 1.7 to higher, it's going to be ionic. So it's more than 1.7, so it's going to be ionic one. As we know, NaCl is salt and it's ionic one. Anyway, let's just look at H2O. H2O. I know the central atom is oxygen, 1, 2, 3, 4, 5, 6 electron. Hydrogen has 1 electron in valence. So this lone pairs will make a bound. So this is the bound between these two electrons. So I want to see that. So what is oxygen? It's 3.5 is for oxygen minus hydrogen. Here is 2.1. What is that? It's for 1.4. So 1.4 is going to be very polar. So it's going to be very polar bound. Okay. So as we say, is the non-polar covalent. This is bound is polar. But look at, just take this example, H2O. This one, we will discuss it later as well. So the bound is polar. Let's just look at CO2. The central atom is C. We know it has 4 lone pair or full valence electron. Oxygen is 1, 2, 3, 4, 5, 6. Another oxygen, 1, 2, 3, 4, 5, 6. See, these pairs will make a bond between these two. These two pairs make a bond. If I want to draw that for CO2, this is C, double bond with oxygen, double bond with oxygen. As you see, there is no lone pair on a central atom, so it will be straight. Is between C and O is CO polar. Look at C. C is 2.5 and oxygen is 3.5. So 3.5 minus 2.5 is equal to 1. You see the 1 is covalent, it's a slightly polar, so it's a polar one. So it would be partial positive here because the oxygen is more electronegative. Electron wanted to spend more time around oxygen. And here is that. I put an arrow to show the direction of polarities from positive to negative. I put an arrow from positive to negative. See, these two arrows cancel each other. I know the bond here is polar. Bond is polar. But is the molecular polar or not? No, the molecular is not polar because these two vectors, see, if you add up these two opposite vectors, they cancel each other. So molecule is not polar. Molecule, not polar. Sure, when we talk about bond is different than molecule. Each between C and O, there's a difference of electronegativity, so it's polar. But if you look at the molecule, it's non-polar because these two vectors cancel each other. But look at the H2O. We did talk about that the bond is polar. Bond is polar. But is the molecule polar or not? Look at that. Since the oxygen has two lone pair between hydrogen and hydrogen, it's not going to be a straight. So this bond is not going to be like a straight because these two lone pair will push the hydrogen bond down. So this is partial negative because oxygen is more electronegative. C is 3.5 and hydrogen is 2.1. Of course, O has a more electronegativity. The electrons spend more time around oxygen than hydrogen. So it's partially positive, partially positive. So the direction of the vector is going to be from hydrogen to oxygen. So these two vectors are the length of them are the same, but when you add them up, do they cancel? No, they don't cancel each other. That's why we say the molecule is polar. Molecule is polar. Most of the case, when you have a lone pair on a central atom, your molecule is not symmetric, and if the bond is polar, so the molecule is polar. But if you don't have any lone pair in a central atom, these two are symmetric, they cancel each other. Okay, so let's just go back to previous page and we talk about the previous one here. So as you see, a Cl2, they have the same electronegativity. This is the electron, and the electron is spent same amount between these two Cl. Here, HCl is more electron, so more electron is spend more time on Cl than H, but this is bigger, this is negative end and positive end. Here NaCl is gonna, as you see, is ionic, and we talk about the reason. This is the hydrogen, this is the water molecules. Here is the sugar. So look at the sugar, this end This CO is polar, but bond between C and H is non-polar. So we have a very highly polar end. So that's why the sugar, we have a polar end and we have a non-polar end. Here again, so this C double bond with oxygen is very polar. And CO2, we did talk about that. We'll talk about the hydrogen bound later, but knowing that if you have a molecule H2O, so it's hydrogen and oxygen. Between the oxygen of one molecule and the hydrogen from another molecule, there will be attraction. So these two molecules attracted each other highly. We call it hydrogen bound. We will talk about that in the other video. If you enjoyed this video, please subscribe. And that's it.